Hey, how's it going? It's Liv. So, I suppose continuing on our impossible mission to do parsing of Perl code. This is not something you should try at home, okay? But anyhow, let's let's move on, okay? So I'm going to reiterate this. There is a common saying: only Perl, the binary, can parse Perl, the language, right? So, and this is because, well, there's a great many reasons why, but I would say the main of which is the incredible flexibility of Perl, the language. It's just so friggin' weird. You cannot possibly get it right, you know. But we're not gonna let that stop us, right? So we're gonna try and do something along the lines of parsing Perl for actually for practical purposes. So what we want to do is a source filter, right? And what I want to do is to read a file and basically modify its contents before it gets to the actual parsing stage, which the Perl binary will handle, right? So what we want to do is to modify the code and then have Perl handle it for us. So it's not such a great effort that we need to make. So that's the point I want to make. Anyhow, I thought I would start off with something simple, and what I'm going to do is I'm just going to create a sort of like a for loop with this style of syntax. And you know, if you don't like it, that's fine. This is just experimental. But anyhow, I'm only doing this as a way to test things out, see how I feel about it, see what works, what doesn't work. So this is not a construct that I have my mind set on. Obviously, it's not very clean. I don't like it very much. But what we want is to expand this into the following expression, right? So like if it were a macro, right? And you know, and the printf. So that's essentially what. And I already have some nodes going in here. So all I have to do is actually just get the tree to look right. But I already have a tree going, right? So you know, it's not very complicated. It just breaks down the statement, and it consumes the curly braces to create hierarchies. And in this case, it is consuming this here because it recognizes that that this is sort of like the argument to this, if you can call it that. But I haven't played much with it, so it's not a lot. But anyhow, what I'm gonna do is I'm gonna take a look at the code and see what we can do. Okay. So I'm just going to work with live Perl itself, which is the source filter. And what we're doing is we read all the lines first. We do a little bit of a pre-processing step in order to transform strings into these tokens, right? So that we can then cut by semicolons and have expressions neatly separated, right? So then we can get more in depth. Then what we want to do is we want to expand the expressions, so to speak. And that's what. Oh, right here. Okay. Sorry, I couldn't find it. So, all right. I'm thinking, because what I'm doing here with this tokenized function, so this is for a language that I'm developing, which has nothing to do with Perl. And you know, because I have the node class, that node class for that language, for the parser for that language already written, I thought, well, I could use it, you know. Um, but yeah, the tokenize function here, it wouldn't work for the uses that I would need for Perl. But it's only really breaking things at spaces mostly, so what I can do is just split myself, you know. So let's just do that. So it's split, and for each split, create a node. Okay. So let's say last init from a substring, and to get our substring, we'll just split. Okay. So for my substring in split at I thought I was going to split at twice at white spaces, but I think I'm going to split at word boundary. I think I can do it like this, right? Maybe I can, maybe I cannot. We'll see. But yeah, let's give it a try. And I actually need to provide a string for this function to work. Okay, so and that should print all the same. Let's try it. Okay. All right, so that's interesting. Okay. Well, let me explain my surprise. I wasn't expecting the comas, but yeah, right. I guess that is a word boundary. Yeah. Um, Dividing by the money sign is also quite convenient because we can know if first and foremost when it appears we would know that whatever follows is a variable name, and we will immediately know its type, right? So it's like writing, you know, int x, right? You immediately know the type of what you're going to read before you even know what its name is. So that's kind of cool. Um, but this might be a little bit too much for our purposes right now. And obviously, I'm not sure I want to cut the the string tokens like this, so this definitely wouldn't work. So we need to be a little bit smarter about this, I would guess. Um, hmm. Now the problem comes in that I could do this kind of subdivision in order to know the the type of a variable, but I would do that at a later stage, right? So I would like to have whatever is separated by commas just stay the way it is, and then do any separation that needs to be made, do it myself. So no, I think I'm gonna first and foremost lower the volume here a little so that the music is not annoying me quite as much, and I'm going to go back to the tokenized function because anyhow it's this splitting out word boundary is not exactly what I want to do right now. So okay, let's go back to tokenize. That's fine. And oops, that's good. Okay. So all right. Tell you what, let's do it. Let's do this. I'll break the expression like this, and then I'll break it down further. So what we can do is try and detect if the very first token we encounter, if it's one of the reserved keywords that we have, we'll declare some of those. If it's one of the keywords that we have for triggering the kind of textual substitution that we want to do, then we'll break the expression further down, and else we'll just leave it the way it is, and then just back it back up. Okay, let's try that. All right, so I'm just going to do with a hash, and if we need more, we'll expand this behind the scenes. Okay. Oops, H. All right. So I'm actually going to give it a name because it's nice then, you know. It's just H, you don't know what it is, and you know, if it's a quick function then it's better, but this one is a little bit more important, so I feel it's better to give it a name. So alright, let's say we have a keyword iter for iterator, and I guess from this we could link a subroutine, so let's do that. Let's say subst iter. Why not? Let's try that. And I'm going to write that function right here. Subst. For a second there I forgot what I had called it. And I suppose I'm going to send it to scalars. Okay. I'm gonna send it the class instance for the filter itself, though probably I wouldn't need it, but just in case. And then also from that the node. Okay. So we are creating a series of nodes and packing them all together into a tree. I want to get the current node in the when we're working down. Okay. Oh, now I guess what I should do is just say node preach, and preach is basically print out your hierarchy. What we're going to do because we are already capturing the first element, and I totally didn't realize this the first time around, you know, that's on me. But I totally didn't realize that I was doing this when I just opened the file. I guess I wrote this when I was about to fall asleep, and so I didn't remember. But now I do remember. Right, so what this is doing is it's taking the first valid name within the expression, right? So actually I should get from the beginning. I should get like the first name or the word. And I suppose I should capture the type as well, no? No, because I'm not going to be dealing with variables directly, right? So if something starts with a variable, then I do not care too much. That would be the way I see it. Now there's a problem here in that what I should check is defined actually is this head thing in here. Actually, oh, oops, this bit. Okay. Else there was no match, and so just initialize a node for the whole expression. That could be that. Okay. Oh yeah, right. I forgot this. So I want to see if that changes the layout of the tree. Probably not. No. No, it's more or less the same, or exactly the same. No, yeah, it is exactly the same. Okay, all right. That's fine. Okay. All right. So what I should do is look at the head thing here. Okay. Let's see. I suppose I could say if exists keywords at the first at the name of the keyword, right? So it would be the first name or the first symbol name or var word, I think is what you could call it within the line, within the expression. So let's try that. And of course, we would also like to, at a later stage, detect these keywords at other points in the expression and not just the beginning. But you know, just to make it less complex right now at this early stage, you know, it's good enough. Okay. So let's just run this subroutine that we've saved, and we'll just call it like this. And unless I made a mistake here, it should print out the node itself. Okay. And it prints out the node, so perfect. Okay. Okay, so what I would do is I would say for this particular one, I would say take the first child and check that it has two values separated by a comma, right? And you know, we can check that both scalars, right? So let's do that. So okay, we can say for my leaf, and this would be array the ref of node leaves. Okay. Well, but actually, I just want to take the first child, so actually this iteration is pointless. Right. So yeah, let's just do it like this. So let's just take the first leaf, right? And if this is not there, then that's a problem. So we can catch that error right here and there. It's not defined leaf. Let us say that symbol iter requires scalar separated by comma. Okay. I'm just going to say this, just to be brief. Okay. And I guess we could try and find out the line number, that would be useful, but I'm not going to do it right now, just because I feel a little bit lazy. But don't worry, we'll get to it. So if we pass this check, we know that we have two arguments, and so what we have to do is say my AP and that B lift value, and we need to actually split this through a comma. And I guess what I'm gonna do is I'm gonna try and eliminate white space. Let's say any number of white space, a comma, and any number of white space. Right? And let's try that. Let's see what happens. Okay. Let's print that out. Alright, good. So what I would do is just convert these into nodes themselves. Maybe. Perhaps. Or maybe not. We wouldn't really need to. I could just block this leaf altogether. Actually, so yeah, let's for now let's block it. And that basically means remove the leaf. And I think the way to do it is I think this is supposed to be an array, so I'm just going to send it like that, and I'm going to preach. And yeah, okay, so that's correct. Okay, so I guess what I'm gonna do is I'm just going to expand. I'm just going to expand this into the 4 and be done with it. Okay. So we're just going to say that node value is equal to. Actually, I want to use a. Or do I? No, I do not. I do not want to. Or do I? I'm sorry. I'm debating in my head. Do I need string interpolation? Actually, I do. So I need my the name of the first field here, then the second one. I need to do as the ref, an array, the ref, right? And then and I actually do not need that that opening curly, because it's already there, you know, in a certain way. In a certain way, it's already there. Okay, so we just consume this first node, and this hierarchy, this open scope, you could call it, is implicit. So yeah, we don't need to worry about that. And let's say wrap, I think. Let's see. Oops. Right. So what I have to do is, and this is kind of complicated, I get it, but just bear with it for a second. Yeah. Oh, right, because I actually need to do it like that. Okay. All right. So it creates basically the wrapping. And you know, it's not much, but it's one example of cool things you can do. So I guess to finish this off, just put it all together and you know, and see what happens. Okay, so it should print for us the numbers 0, 2, and 4. Okay. So let's cancel the breach. And let's see. Now what I have to do is put the tree back together. So to do that, first I'm going to look at the hierarchy once again. Okay. All right. So there is one small problem here. It's not. It's nothing serious, really, but So the problem is that I don't want these kind of keywords that I'm not going to do any substitution for to spawn any additional children. They should just be the way they are, right? They should just come as they are. You know, to put it in a Kurt Cobain kind of way. So, I guess I'm just going to tokenize in that in this case where the keyword is defined, and else just going to put the whole thing together, and that should be alright. Let's see. Ooh, I need to stop deleting lines that I need for debug, you know. Okay, so that's better. That's way better. And I don't mind the lacking of the spaces, and as a matter of fact, Perl also doesn't. But it's not very nice, so I'm gonna take that out. Okay. All right, much better, much better. Okay, so yeah, this is fine. So now, if I just walk the leaves of the root, and I can do away with this now. I think so, at least. So for my leaf in the root leaves, so for every children of this root node, I want to walk this, and if leaf leaves, so if this node has children, then we want to walk through those children first. So it's going to be a little bit confusing, but hopefully it'll make some sense. So we only have 2 levels deep, at least for now. But still. Yeah, this is sort of the problem with this kind of thing. You sort of have to go into recursion a lot. And there's actually I could solve it with a goto, but a lot of languages do not have goto because a lot of programmers are superstitious about it. You know, just what happens. You know, when you don't have the confidence to understand how things work, you just take someone else's word for it, right? You know, you identify someone that's probably pretty smart, like Dijkstra was, right? So well-respected guy, obviously a very competent scientist, and so you know he said, go to it's kind of sus, you know. And so now everyone is like, oh, do not use goto, you know. But you know, its use, its well-placed use is always valid. Do not be afraid to use it. In case in point, I'm going to do a little bit of I think they call this tail call optimization or something like that. It's actually not that difficult. So I'm just going to say top. And what I'm gonna do is, if my grandchild, you know, grandchild in the sense of a relationship of these nodes, not my own grandchild, I do not have any, sadly. I'm gonna take give me a second so I can process this. Huh. Well, what I guess I'm going to do is I'm going to create a list. I'm going to append to it, and I'm going to say and I'm going to do away with the loop altogether. I'm just going to roll it manually so that I don't have to, you know, in a sense it's going to be recursive, but it's not going to make multiple function calls to itself, which in a sense I guess it's better. I believe it is better generally. So wait, forget about this. I'm going to push to leaves the leaves of leaf. Okay. And I actually have to dereference it. So they'll sort of stack. I guess I will start out leaves as being the ref of, how do you say? And I think this is the way I have to do to make a copy, but I'm not sure. Anyhow, let's take the leaves of the root. Okay. And now at the bottom, if leaves go to top, right? So it will continue iterating until there is nothing left on the leaves array. So that's basically that, at least for now. What I will do is I'm just going to breach the leaf. Okay, let's see what happened. Okay, so it's out of order. Not precisely what I want, but it's a start. So I guess I need to shift here, maybe. All right, so now it's more correct. Okay. So the first thing is I'm gonna have a string here, and if a wait. If a leaf has children, that means there is a hierarchy, which means there is a scope open and close, which means that I need to paste the curlies, right? So problem with that is I need to know where the leaves of that leaf end. So I guess what I'm going to do is have a marker at the end, and that's gonna be that. So because else I don't think I have a good way to know. Do I? Well, I could just push into leaves just undef and if not defined, and this might be a bad idea, but we'll just go back to the top and put in the curly right there, right? Else, we'll just put the other side of curly. Okay, so that didn't break. Not defined. Right, so we've not defined and leaf, right? So we've not defined and there is and not leaf and leaves. So if leaf is not defined and there is still something on the array, right? I would say go to top, but wait, let's do it like this. Not defined. If we still have things to go through, then we'll go to top. Else we'll just break from this. Okay. Oops. And there you go. Okay. So I suppose you could do this in a more straightforward way if you weren't using jumps like I'm doing. That's fine. There's an argument to be made that if a language gives you flow control keywords to achieve the same effect, that generally speaking you should use those. Now in this case, because this would force me to go into a recursive call, and I don't like doing that. I'm just going to take the cheap way out and use jumps, which you know this is actually the more straightforward way, believe it or not. At least as far as I can tell with my how late is it? My 4 a.m. brain. With my 4 a.m. brain, this is as straightforward as it gets. Okay, so let's try it. And oh right, and I want to append to our string the value of a leaf. Let's see. Okay. So this is not exactly right, but it's interesting. So this is not exactly right, but it's interesting. Okay. I actually need to append at this point in here. Right? Give me a minute. Okay, so this is definitely wrong. Okay, give me a second. Not entirely sure. Right, let me disable the preach. Okay. Right, so here's why. There was never a closure. That's interesting. Let's see. Okay, so it's adding So it's opening up a scope every single time. That's not precisely what I want. Hmm. Not quite so good. You know what? Let's try something else. Let's try something else. And I guess I'll leave this no, label in there. Okay, so let's not go to the next. Let's see what happens. Okay. Okay, so that's a slightly better. That's slightly better. All right. That's more like it. That's more like it. But for some reason, it's not yielding the elements in the order that it should. I suppose because it goes through the children like this, right? So it has to stop when it encounters one of these, do all of its children, and then continue with its own children, right? So I sort of well, I guess I need to put 2 levels onto this, I guess. Huh. Hmm. It's a strange thing trying to solve this kind of problem without going recursive. Uh, I once heard some guy that I think he was teaching curses on COBOL of all languages, and and he was like this very, mm, how do you say, obnoxious kind of character, and he was saying, "Oh, nobody appreciate in the here's the words he used. He said, "In the real world, no one appreciates recursion." Like really? I mean, I get the core of what he's trying to say, that yes, recursive functions are annoying and more difficult to understand. So I generally don't like them, but it's not useless. It's not like something entirely useless. I mean, he committed the same crime that I'm always denouncing regarding critiques of GoTo. It's a tool, man. You use it when you really really have to use it. You know, and sometimes when you just need to use it. Sometimes you don't need all the extra really. Just a small need is good enough. Um, it's not a question of how on focusing how someone that's not properly educated will abuse the tool. It's about you know how someone that's properly educated can use it for good, right? So it's like, I don't know, it's like when they want to ban something because some idiot use it for evil, right? Like, uh, oops. I don't know, I used to feel like really annoyed and really mad and really depressed that how terrible most software developers are. You know, sometimes including myself, but myself for other reasons. Mostly because of how I am a little bit insane. But um, in reference to someone that's more able-minded, let's say, um, I don't know, they just give in to some sort of weird combination of hubris and yeah, and just hubris, you know, just oh we are so important. We type code all day. We are so important. You know, we code JavaScript for a living and shit. Like, get over yourself. I mean, most technology that we rely on doesn't really work all that well, you know? Like, I don't know. Government web pages, they're always shite. Universally. It's like, you know, progress, you know, the future is here. But, you know, you try to go into, I don't know, to get some documents or, you know, just do uh, some bu bureaucracy kind of thing, right? So just getting papers so you can get more papers and things like that, you know, the kind of shite you need to deal with. And their sites don't fucking work. Amazing. The future is here. You know that, you know, progress is a little bit of a lie. And I mean, who wrote the code that runs on their servers, right? Who wrote that? It had to be a software developer. And it's likely, you know, it's either a CS undergraduate that, as we speak, is probably hating every one of his life decisions, or two, someone that actually knows their stuff and just didn't care to do things right because he was not paid as much as he wanted to. So he just did a mock-up job and well, and said, you know, he lifted two fingers in the air and went on his way. And now millions of people have to pay for now millions of people have to pay for what he wasn't paid, you know. And it's like, just get the job done, you know? Just get it done right. And if you want to leave, just leave, but you know, do the job right, man. It's like, too many people depend on this. You cannot do a mock-up job. You know, I can do a mock-up job. No one watches my videos. No one reads or uses my code. So why, you know? But still, I try to do an okay job if I can. Um, yeah, I don't know. I'm disappointed. I'm not angry anymore. I'm just disappointed that that most software developers that I'm coming in contact with, that they have this very pretentious style. I guess I shouldn't say pretentious, but yeah, you know, they want to be like high class, you know, like high class, right? They want to, you know, their whole thing is they want to get money. Their whole thing is they want to get money, and they, you know, they don't care for like the repercussions of things they do, and that's really bad. That's bad, man. So anyhow, do I need to make this recursive? The answer is, in a way, yes. In another way, I do not want to. So let's try and do it non-recursively. And the challenge is we need to start. So we need to iterate the children, and if we find a grandchild that has children nodes as well, then we need to go through all of those before we we go through all the others. So I suppose I need to do with a how do you call this, a slice. Let's try that. So it should be leaves. Well, I guess the next one, the next leave on the list. Huh. Wait. Let's do an on-shift. Maybe that will work. Cancel this. Put this. Okay. So that works. Okay. So non-recursive. That's that. Alright. So fixed. Fixed. Okay. Right. That was easy. So let's oops. Let's try doing a little bit of something here. And try putting the wraparound how do you say, the Dawn curlies, right, the curly braces. So if we do it like that, we get, no, we get a curly there. That's wrong. Okay, all right, so I'm just not going to bother. Not worth it. Not worth it. Okay. All right, that's okay. So the only problem is now when I preach this, it's yeah, it doesn't look quite the way I like, but that's fine. That's fine because the string that it gives me is correct. So yeah, I just have to deal with it. So anyhow, now what I want to do is keep the semicolons. Now that I think about it, so keep the semis. Okay. Because it's fine. Yeah. I'm fine with the semicolons. I'm going to say this with an array. So I'm not going to put a new line if the value of leaf is just a brace. Okay, just because. Actually, I think it's the other way around. Nope. So if it's equal, no, if it's equal to a brace, then I do want, let's say, if it matches a brace or an opening brace or semicolon. Let's try that. Okay, that's fine. Yeah, I suppose that's fine. That's readable. So yeah, okay. Alright, so that's basically that. Let's just return. I'm going to restore this, and restore basically all it does, all it should do at least, is put in the tokens that we converted from strings. It should replace them for actual string. My mangled So I'm going to actually split this at new lines. Why not? Or, well, actually, I think I can do it in just one go. Okay, so it doesn't like that. 4, 3, 6. Oh, yeah. 400. What you talking about, Willis? Oh, my my bad. I need to kill this. Okay. A sec. Okay, so it did the printing, right? So 0 to 4, that's fine, but for some reason it's complaining about something. And here. Oh. Let's go to this one. Nope. Hmm? Okay, so that's silly. Okay, so weird. So this is the bit that it's complaining about. Yep. Alright, weird. Okay. Alright. That's better. Okay. Alright. So okay, so we created the iterator. Let's try using strings here just because. So let's say hello there, and a bunch of exclamation marks, I don't know. And let's try some interpolation. My S would be help me, Obi-Wan. And let's put it in here. Okay, so there we failed. Oh no. Alright, so help me, Obi-Wan. Hello there. Okay. Alright. So that's basically a wrap, I think. So obviously, like I said, I'm not going to use this construct, this it's a construct. I don't think so. But this was just, you know, to test out what we could and couldn't do, and generally we can get away with quite a lot. So yeah, that's fine. I'm just going to get rid of the 4 in here. Yeah, because if it's going to be a one-liner, then it doesn't make any sense to just do it. I'm just going to Actually, I can just return it outright. Yeah, why not? And that's a wrap. Okay, that's it from me. Have a good one. Bye.